Section 1.6 covers angle-pair relationship, the key word here being pair, so a set of two angles. In Section 1.5, Mrs. Jankowski covered the idea of adjacent versus non-adjacent. So a pair of adjacent angles have a common side. So an example would be angle APD and angle DPB. They have a common side of ray DB. A pair of non-adjacent angles do not have a common side. So an example would be angle APC and angle DPB because they don't have that common side in the middle like adjacent angles do. The second set of angles that we are looking at are called complementary angles. Complementary angles are two angles whose sum is 90 degrees. Remember, the sum is the answer to an addition problem. So together they add up to make 90 degrees. They can be adjacent or they can be non-adjacent. This first example is complementary angles that are adjacent because they have a common side. I also know that they are complementary because of our little box, and that box represents a right angle, which we know is 90 degrees. They can also be non-adjacent, like the second example. Angle A and angle B do not share a common side. However, 20 plus 70 is 90 degrees, so they are complementary. Supplementary angles are two angles whose sum is 180 degrees. Once again, they are able to be adjacent or non-adjacent. Our first example is adjacent because they have that common side, and it's also a straight angle, which we know is 180 degrees. Our second pair is non-adjacent. They do not have a common side. However, 115 plus 65 is 180 degrees, which makes them supplementary. A linear pair is our fourth example. They are two adjacent angles that form a straight angle. The angles in a linear pair are supplementary since a straight angle is a line and a line is 180 degrees. It must have a common side. That's what makes them adjacent. And they are supplementary, being a straight line, which is 180 degrees. Our last pair of angles are vertical angles. These are two angles whose sides form two pairs of opposite rays. So in this example, angle 3 and angle 6 are one set of vertical angles. The second set of vertical angles are angle 4 and angle 5. Vertical angles are angles that are across from one another, and they are also congruent. So the measure of angle 3 is equal to the measure of angle 6. The measure of angle 4 is equal to the measure of angle 5. In the figure, they want us to name complementary angles, a pair of supplementary angles, and a pair of adjacent. So remember that complementary angles add up to 90 degrees. So if I look at my two sets of angles, I recognize that 37 and 53, when they are added together, it equals 90 degrees. So my complementary angles are angle CAB, making sure I put the vertex angle in the middle, and angle RST, vertex angle in the middle. Supplementary angles add up to 180 degrees. So I need to find two angles whose sum are 180, and that would be 127 and 53. So the 127 angle is angle CAD, and the 53 degree angle is angle RST. Last, we need an adjacent angle, so these two angles need to have a common side. The only common side that we have is ray AC. So our two adjacent angles are angle BAC along with angle CAD, since they have that common side of ray AC. So we have angle BAC and angle CAD. So we're going to use this idea of complementary and supplementary to solve algebraically. So for part A, angle 1 is a complement of angle 2. Remember, a complement is 90 degrees. If the measure of angle 1 is 62 degrees, find the measure of angle 2. So when we add together our measure of angle 1 and the measure of angle 2, the sum is 90 degrees. The measure of angle 1 is 62, plus we do not know the measure of angle 2, so I'm going to let that be x for a total of 90. I subtract my 62 from both sides, and x is 28 degrees. So the measure of angle 2 is 28 degrees. Part B is very similar. However, this time they're talking about supplementary angles, which is 180 degrees. So if we know the measure of angle 4 is 47 degrees, we want to find the measure of angle 3. So the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees because it's supplementary. I'm going to substitute the measure of angle 4 since I know that is 47 degrees. And that equals 180. I use my algebraic skills to solve for x, and x is equal to 133 degrees. Therefore, the measure of angle 3 is 133 degrees. Example 3 is looking at the view from the side of a frame of a ball return net, and it forms a pair of supplementary angles. This is also a linear pair because it has a common side. Either way, we know that supplementary angles and linear angles, the magic sum is 180 degrees. So they want us to find both the measure of BCE and the measure of ECD. So we need to use our geometric knowledge that the sum of the two angles is 180 degrees. We also need to use the angle addition postulate that when I add the two angles together, they equal the sum of the entire angle. So angle BCE is represented by 4x plus 8. ECD is represented by x plus 2. And the sum of those two angles is supplementary, or 180 degrees. So I will continue to solve algebraically. I combine like terms to get 5x plus 10 is equal to 180. I subtract 10 from both sides to get that 5x is equal to 170. And then I divide both sides by 5 to get that x is 34. To find angle BCE, I'm going to plug x into 4x plus 8. So I have 4 times 34 plus 8. 4 times 34 is 136, plus 8 is 144. To find the measure of angle ECD, I'm going to plug it into x plus 2, which is 34 plus 2. That total is 36. And I can always do a self-check since this is supplementary. When I add together 144 and 36, I should get 180, and in fact, I do. Example 4 wants us to identify all linear pairs. So a linear pair is two angles whose sum is 180 degrees and it forms a straight line. So we have two sets of linear pairs. Okay, so here is one line, and it is made up of two angles with a common side. So angle 1 and angle 4 are a linear pair. We have a second set of linear pairs, and here's our straight line with our common side, and that is angle 4 and angle 5. Vertical angles are angles that are directly across from one another. We have one pair of vertical angles, so here's our two sets of opposite rays. And the angles that are across from one another are 1 and 5. So our one pair of vertical angles are angle 1 and angle 5. Solving for a linear pair, so I'm just going to set up a picture. So I have two angles that form a linear pair, so that means we have a straight line and a common side. The measure of one angle is 5 times the measure of another angle. Well, I don't know what either of these angles are. So I'm going to let my one angle be x because it is unknown. My second angle is 5 times the measure of the other angle. So if I let my other angle be x, the first angle then is 5 times that angle, or 5 times x. So now I'm going to use my angle addition postulate. The sum of my two individual angles equals 180 degrees because a linear pair is supplement. Then I'm going to use my algebraic skills to solve. Combine like terms, divide by 6, and x is 30 degrees, or 30. When I plug it in for the measure of angle 1, that is just x, so that is 30 degrees. The measure of angle 2 is 5 times 30, which is 150 degrees. I can self-check. 30 plus 150 is 180. The last example deals with vertical lines, or vertical angles. So vertical angles are the angles that are across from one another when there are two sets of opposite rays. So we're going to solve for x, and in your notes, you're going to solve for y. So vertical angles are congruent to one another. So that means that this space, or this angle of 12x plus 5, is the same as this angle, which is 75 degrees. So I'm going to set my equation, or my expressions, equal to one another. So 12x plus 15 is equal to 75. And then I'm going to use my algebraic skills to solve. So 12x is equal to 60 after I subtract my 15. And then when I divide by 12, I get that x is equal to 5.